Today, I wanted to talk a little bit about the troubleshooting process and sort of take you through exactly what I'm thinking when I take a look at any repair really that comes in. We're going to go through this repair that a customer sent in, and I'm going to take you through step by step exactly how my brain sort of processes what to do next and why I want to do that next with this particular repair, but also with repairs as a whole. So let me get this open and we'll take a look at what the customer said about the device and we can go from there. I think certain repairs, like no power repairs like this, are a little bit difficult as a beginner to know where to start. So hopefully this is going to give you some idea of what I like to do. So first of all, props to the customer for packaging this well. You can sometimes have issues if you're doing mail-ins with poor packaging, and damage can happen to the device. That might be unrelated actually completely to the initial fault. All right, and right away I can tell this has obviously been opened because we have, a custom shell on here. So immediately, if there's any indication that the customer has been in the device before or someone else has been in the device before, and I can see a number of things already because we can see through the back. One of the most important things to do is a full visual inspection of the entire board. The first thing I'm seeing here is obviously that the case has been changed, but one of the reasons I know this back cover has been opened is because of the customer note, which we'll get to in a moment here, but also because you can see the antenna wire is moved away from this screw here, and normally it is like over this screw, which I'll show you later. So very clear that both of these covers have been taken off and that someone's been in the device, and it makes sense in this case, and you'll see why in a moment. So right here, all we get with this customer note in particular is has a mod chip installed and no longer boots up. So because I have a lot of experience with these mod chips, I'm going to know where to look, but we still want to do a full visual inspection on the board. And I've had all kinds of issues. I'm just looking in here first if there's any game cartridge, and I also want to check if there's an SD card, and there is, so we're going to just pop that out. And I'm just going to go ahead and throw the customer's SD card in a little protective case like this so we don't lose it. So this is just personal preference for me, but when I know someone's already been in the console, or if I know, for example, there's been liquid damage and the customer told me they spilled water on it or they dropped it in water or something like that. Those are the two scenarios where I will not try to power the console on. I don't see any reason in, replicating the issue if we know what sort of caused the issue, if that makes sense. So in this situation, because we have no idea what the customer did to the board, there could be solder all over the place. I'd prefer not to, attempt to apply power to the console in any way. So I'm not going to plug a charger in here, and I'm not going to boot the console because we might just be damaging things further. So first and foremost, I would like to get this thing taken apart and take a visual inspection of the board. So let me go ahead and get this thing opened up and we will take it from there. Real quick, I just wanted to give a shout out to this cool series of giveaways my friend Justin from the Auto Repair is hosting on the r/soldering subreddit. They're doing a giveaway every week, and they're partnering with brands like iFixit and Pace and JBC. So you have the chance to win some really nice tools for free. And according to Justin, not a ton of people have entered yet, so you actually have a pretty solid chance of winning. Just a quick heads up that the giveaway is restricted currently to North America or UK and Europe, so just be aware of that. Oh, and every single winner will also get a 10cc tube of the V2 Amtech 559, which I haven't tried out yet, and I would love to try that out. And you also get access to Justin's soldering e-learning course, which is absolutely phenomenal material. The guy is born to teach. And this week, I'm working with Justin to give away this iFixit bundle, which has a ton of cool stuff in it. It's got their portable soldering iron, which I'm interested to try this out. It's a really cool looking portable iron. And you get some really nice wire cutters, wire strippers. So this is a great opportunity to win some really nice tools if you are just getting started in soldering and need some equipment. I'll be announcing the winner for this in the video I post next week on October 16th, next Thursday. So if you guys want to win this, or if you want to enter in future giveaways, click the link in the description. So yeah, just wanted to give you guys a heads up about this giveaway, and we can jump back into diagnosing this board. So again, in this case, it's very clear the console was opened up already because this antenna wire is moved. Usually it is over like this, over that screw. But let's say, for example, that wasn't the case and this didn't have an alternative case back on it. What are some signs I would look for? Well, first of all, I would look for things like this, where there's fingerprints, or if there is thermal paste spread in places where it shouldn't be. And that's obviously a good indication that something has been messed with. One of the really easy things to catch is if screws are in the wrong places, if the wrong size screws are put in the wrong places, or if screws are missing, or if none of that is the case, you can actually look at the screws themselves, and you can actually sometimes see some visual damage on the screws. So here's kind of a good example. You can see some of the metal on the screw has been sort of damaged a bit on this little corner here. This is a good indication to me that someone has stuck a screwdriver in here. So there actually isn't too much damage on these, but if someone uses a wrong size screwdriver and stuff, you're going to see a lot more of this kind of stuff than you're seeing here. But sometimes consoles will also have little warranty stickers and things in place that you can look out for. So for example, on the Switch, there is normally a white little square sticker here. Also, if the antennas are routed in ways that they normally aren't. For example, here, I know this particular antenna wire is always stuck underneath this little clip here. And you can also even see some like scrapes in the back there. So that's also a very good indication to me that even if nothing else looked off, that, you know, someone's been in the console. So anyways, while I'm opening devices, even though it's always the same sort of process to open these devices, I'm constantly paying attention during disassembly if anything seems off or if there's any clear indications that someone's been inside before, because that is really, really important information to have when we go to diagnose what's going on. So enough talking, let's just get into this console and see what's wrong with it. Anakin's wanting to get in this customer's box, which I actually don't mind giving to him because I'm going to be using a different box anyways. Look at him in there. He's having a blast. Can I help with the repair? He's purring. He loves boxes. All right, so first thing I'm noticing as soon as I take the cover off is two things. Battery still plugged in, so that's something to note. I'm just going to go ahead and unplug that quickly. And then we also see the liquid damage indicator has turned a little pink. Now it's important to note that like 99% IPA is not going to make this turn red. So it's possible that they use some sort of weird like cleaning solution, or they use some sort of weird flux that ended up triggering this. Maybe the device, you know, previously had liquid or high humidity in it in the past, so could be unrelated to the issues we're experiencing, but it's definitely something to take note of. I'm also noticing that, you know, there is some discoloration on this copper. It doesn't normally look like this. So this could be due to a number of things. It could be due to the particular thermal paste that was applied there. It could be due to like heat, like maybe a lot of heat was applied to that shield. We obviously in this case have a PicoFly chip in the console, so we're gonna wanna check in all of the places where this thing is attached. Unfortunately, I do see that they have done the kamikaze method, so it's entirely possible that they dug through too many layers of the board. So what I wanna do right now before I unplug this is check all these different points here with diode mode, and we should be getting around 0.4 voltage drop on basically all of them, except for the 3v3 line. This is the 3.3 volt rail that connects up here to this 3.3 volt rail on the console. This one is more around 0.3 voltage drop. So I've got my meter set in diode mode. I'm gonna get ground from the battery terminal here. And we're gonna look up here on the top left where it says overload there. We're gonna see what each of these say. So we got 0.36, which is pretty normal. And I just know this based on past experience with these chips. So this has 0.45, that is normal. 0.42, that is normal. And this is one of the things I was worried about. So this is reading a short to ground. This C point here, this is the .0 point, which goes into this kamikaze area. So that is definitely going to prevent boot already. It's possible this is not even connected to the right point, but it is definitely shorting to ground, you know, somewhere along the line. So that's not good. We also have, we can check B, 0.4, that looks good. And we could check this CPU point, which is generally a little bit lower as well. Yeah, 0.36. So everything so far to me is looking good, except for the worst thing possible so far, which is this kamikaze wire. And then obviously also our liquid damage indicator here. So what I'm gonna do is take the chip out next. So let me just undo this little lock here and we can get the shield taken off. So I'm gonna do everything I can here to clean this thermal paste off so we can get a good look at the soldering that was done under this tape. All right, so honestly, the soldering under here is looking not so bad. We're gonna have to obviously clean all this up to get a real look at it, but I'm not seeing any bridging or anything like that we need to be extremely worried about. In some cases, I will take this off if the soldering looks really bad. In this case, since after fixing the console, I'm going to reinstall this anyways, it makes no sense to take this off because it actually is installed relatively okay. I'm going to go over these solder points again because I like to get them looking a little bit different than this. But overall, I don't see any bridged caps or ripped pads or things like that. So I'm not going to say that this is causing boot issues and we can kind of move on. I do see a little bit of solder down here. I think this is maybe on a test point or something. So you can see work has been done over there. We'll definitely check out where this B point wire is going and see how that looks once we take the board out of the console. Before we go too much farther, I just always like to look at the state of the battery, and if it's charged, helps me know if I'm going to be able to use this battery to test. So we're getting about 2.39 volts out of the battery, which means it's a dead battery. Anything under like 3.7 volts is going to be a low battery for this particular battery, and then lower than even that is going to be dead. So this is definitely not going to turn on with the battery. Now, normally solder on pads like this really indicates like a knocked off component or a missing component. In this case, I know for a fact there is never a component here, just based off of my knowledge of these boards and having worked on many switchboards. This is not something that is normally populated. So I think this is just solder that is here from him trying to solder this point or this, or maybe the kamikaze point, and just slipping with his iron or with the solder. So something to note here that, wherever this person has worked, you can see there is solder nearby in places where it shouldn't be, like here. Oh, and I can see some interesting looking like flux over here. So this is good to know that we have some, flux all over the board. This is the clock point here. This is the scraped up via, and that looks like it is intact at least. We are going to remove this flex cable. So yeah, just sort of thinking out loud and letting you guys know sort of my thoughts as we go. All right, so I think a good next step is going to be to take the board out of the console. So let me just go ahead and do that. I'm also realizing this little flap here for the screen connector is very difficult to pull up compared to normal. So this can indicate that there's flux in there and stuff. So we're definitely going to want to inspect DisplayPort. I always inspect that anyways because it's really common that gets destroyed. And it's common that that's on top of other issues on the board. Like we already saw a short. So this might be damaged on top of that, and it'd be good to see. So a good sign already with this FBC connector is if the FBC connector is damaged, a lot of the times you'll see damage on the FBC cable here. And actually we do see, some scratching that may be just from tweezers. I also see potentially a scraped trace here on the FBC cable. So there is some damage here. And this just goes to show that, just inspecting the board is not always enough. Sometimes there is damage on the chassis or on other flex cables and things like the power volume flex. I've had a lot of times where it's damaged here and the power button traces are severed and the console actually works fine. It's just that the power button is not working. That's happened to me multiple times before. So really worth checking flex cables. You can see on these FBC connectors, there's like this rigid part that starts very clearly like right here. And a lot of times you can see like this gets sort of damaged here over time if you insert and remove this flex cable repeatedly. You can even actually see it starting to happen down here. You can see on the part of the FBC that is bending, some wear starting to occur right here. I think that trace is exposed, but it's not broken yet. But this looks like it, could be melted through or broken. Not too sure. These look a little bit more creased than normal to me as well. So if we do get power on the motherboard, but we don't get any display, we could always try a new display. But yeah, just being thorough is very helpful for efficiency's sake, in the sense that I know this battery's dead, I know this is potentially damaged. So what I'll probably do is just end up throwing this in a known good screen with a known charged or good battery, so that I can, be absolutely certain if the board is repaired, and then we can put it back in the customer's screen here and see, if we see any differences. If so, we know something's wrong with, something on here. All right, so we have the board out now. So we've already sort of taken a good thorough physical inspection of the top of the board. I don't see any issues on the battery area. We see some scraping. This is very common because these speaker connectors are a little bit difficult to get out. So you'll sometimes see scraped or torn traces around those. So we can look at this one as well, but I don't see anything. You can have knocked off components and things if someone is very rough with it. Similarly, around shields, like if shields have been taken off previously, sometimes you'll see scraping through traces or little resistors and things knocked off around the outside edge of the shield. In this case, this is part of the mod installation. You do cut this part of the shield off, so that is normal to see with these. But again, you can see actually this person did a good job, which is rare. Almost every single one of these I get has the corner of the SoC here damaged. So this person did a really solid job cutting this carefully, and doesn't look like they cut through traces. I also often, if you get like a blue screen on the switch, it's oftentimes the traces in between the SoC and the RAM here, this top RAM chip, are severed because the person who cut through the shield also press down too hard on the board and cut through some of these traces. That will prevent boot for sure. We're going to remove this again and inspect this a little bit more closely. That is a point that you need to scrape up. So sometimes people dig that out a little bit too much. I do want to look inside this port. You can see, I don't know if you can see what I mean, but this is being very, very difficult to push up and down. You can see it's kind of coming out a little bit there as well. So this is often with these an indication that there's like flux in the ports, or that the FPC like lock is not sitting in the right place. So let's turn this on its side and take a look under the microscope if we see any bent pins. Unfortunately, we don't have any bent pins, and it does look relatively free of flux. We can still try to flush it out with some IPA just to make sure there's no residue in there, because it is more difficult than usual to move this little lock. But that's not going to be causing boot issues for sure, because we don't have like shorted pins or bent pins in there. That's one of the things I want to point out is like, even if the like plastic on this was damaged or something and we did need to replace this port, if there was no bent pins or like shorts on the pins, I'm not going to touch the port for now, even if we do need to replace it later, because this is not going to prevent the board from booting. And really all we care about at this stage is, can we get the board to a stage where it's booting? Because if we can't, then what's the point in replacing and spending time on replacing the port that's not going to be causing boot issues? It might cause display issues later on, but if we can test that the board is working, which I'll show you how I'm going to do that with this particular board in a moment, but if we can test the board is working before resolving other, nice to haves like a screen or speakers or things like that, if the board doesn't even boot, to begin with, like what's the point of wasting your time? So I always recommend skip stuff like that. If you know it's not causing boot issues, move on. There's no purpose in having sound on the console if the console's broken to begin with. So we're also going to take a look at the back of the board here. We took a good hard look at the front. You can see they did have at one point a .0 adapter in here because this shield is cut. I could also tell that the shield was bent up a little bit here, so it's clear that someone had pulled this off before. So we have some solder here, but this is not, bridging to anything. This is just, again, from the .0 installation. Just mental note of that. Again, looking for any dripped solder or anything. I do see some damage to the board here. The PCB is a little bit peeled up on this side. Let's get a good look at that from this angle. So it looks like the board was dropped probably. So that's good to know, because sometimes a board that's dropped can crack solder balls underneath the SoC. I don't think that's going to be the case here, because we know for a fact there is a short on one of the lines going in between the SoC and the NAND. But it's totally possible we have multiple faults. It's totally possible we'll have cracked solder balls on top of short somewhere. Especially with mod attempts or boards where someone who's inexperienced with microsoldering is working in a lot of areas on the board. I have had plenty of boards come in that have 5 or 6 issues with them. You can check out my most recent mod repair on the channel. That thing had like 5 or 6 issues with it. I'm also seeing the B point here. There is no ripped trace. A lot of the times this trace gets ripped up. Too much tension gets put on this wire sometimes, or too much heat gets applied to this test point here. And there's actually a trace going through that test point. So it goes from this via here through the test point to the top of this resistor. And if this gets ripped, this can also prevent boot because it severs the connection for the B point or the reset point. And I'll just quickly mention stuff like this and like the component here that looks like it might be missing, but I know it's not. This context I have for how these repairs normally go is really a big part of the reason I have a high success rate with fixing mod attempts like these, because I've focused on the same types of consoles over and over again. I'm not branching out and trying to repair a ton of retro stuff. This is why I often recommend and talk about, when you're just starting, focusing on one particular console and get really, really good at repairing that particular console, because you're going to, first of all, learn a lot about, just electronics in general when you focus in on like one specific board, and you're also going to build a lot of context about that particular device. And this is an incredible way to start building context in the world of repair. So I highly recommend, if you're just trying to break into repair, you're confused where to start, you're having issues with how to start your troubleshooting, a really great way to sort of like limit your scope is to just focus on one type of device and buy a bunch of broken ones and try to fix them all. Because over time, you're going to build context like this, and you're not going to waste your time on trying to figure out what component was here. you know, that kind of thing as a beginner can really throw you off for a long period of time. So I just pulled that wire off really quickly and we can sort of clean up the area. One thing I want to note about this, and like what I did on the SoC over here, is that I am sort of looking at the customer's work or the person's work before I modify anything myself or clean anything myself, because cleaning and modifying things or soldering things yourself is sort of altering or removing sometimes evidence, and this evidence is sometimes extremely key in figuring out what's going on. So I didn't just immediately go ahead and clean up these areas. You know, I'm sort of looking at them first and seeing if there's any, you know, evidence there that I should take note of first before cleaning up the area. One thing I'll do is actually, because this liquid indicator is triggered and it's right next to this shield, I do want to take off this shield to see if there's any sort of corrosion or anything that we can see underneath here. I do see, you know, a little bit of what may have been liquid at the bottom there. You can see this chip is supposed to be 100% shiny there. We can see at the bottom there's something on that chip there, or was something that looked like dried up. I also see a little bit of liquid or flux on the side here. And actually we can look at the shield itself, and yeah, you can see, I think there was some kind of liquid in here at one point, specifically I think on the right hand side here. Fortunately, I don't see any corrosion, or visible corrosion at least. This here is a BGA chip. This is the Bluetooth and Wi-Fi IC. That is looking fine so far. So I'm just gonna pop that shield back on. We can come back to that if the board doesn't work still after working our way through other things. This could be a candidate for ultrasonic cleaning if we don't want to guess or have to take off, you know, the whole SoC and the RAM chips and the Bluetooth Wi-Fi IC. We could just use ultrasonic cleaning, which I might do on this board if we can't get it to work after resolving the short. So that's the next thing we're going to take a look at. Again, I'm going to leave this flex cable on here for now. I don't think that's causing issues, and we're going to take off this flex cable. So we're just going to pull this thing off. Also going to want to unsolder this here, and I'm going to turn my iron down for this particular point because this A point here is often very heat sensitive, so I'd like to not apply heat there for a very long time. Rotate the board so it's easier to pull this thing off, and then the bottom. And here we can see there's no extra solder in that area, and we're not seeing any issues with the 3.3 volt regulator over here. There's no chips or things on it, but oh, we do have some extra solder over here. So this is what happens when solder sort of drips onto the board from, you know, trying to solder maybe the C point or I don't know, something else. So that's not good. That's definitely something we could take a look at. And I'm not going to clean that up right away because it's very possible that's the cause of our short. You know, I want to verify and measure the short first again, especially after having removed all the mod chip stuff. I want to verify the short is still there, and if so, when I clean this up, does it resolve the short? That's sort of the step-by-step process I would want to take here. I don't want to just go ahead and clean that up. So especially when you're starting, it's really easy to get ahead of yourself and just start like fixing things that you see. But you really need to take your time, especially with repairs like this where previous work has been done on the board, and, you know, use your critical thinking and troubleshooting skills. So I'm happy cleaning this up, and I do not think that trace is fully scraped through either. Over time, you'll get used to the difference between just seeing, you know, scraped solder mask like this and like a fully torn trace. Sometimes it can be hard to tell. You have to clean a little bit sometimes, or scrape a little bit more yourself to see. But in this case, I can tell you for sure this via is completely fine. And this area here just has a bit of extra solder on it. So I will just throw down a bit of flux there, and we can quickly clean that up. So I think the end cap of this resistor is actually peeled off. You can see it's not fully on the resistor anymore. I don't know if you could see that. Let me try to gently clean this and show you what I am seeing here. See how it's not all solder and it's just like this end cap just is damaged. Maybe you can't see that super well, but I know this resistor is not necessary, again, just based on experience with these consoles. And resistors do not really ever fail by going short. They fail by going open circuit or higher resistance. They don't ever really go lower resistance or short out, you know, unless there's like solder bridging both sides of it. So in this case, I know this resistor, one side of it here is attached to ground. And I know for a fact if this resistor is missing, the console will still boot. I know because I've tested this with this specific resistor in the past. So again, I'm not going to bother wasting my time with this resistor anymore, and we're just going to move on for now because I know that that is not going to be causing our issues with the console not booting. So my guess as to our issues is here. And after a second look at this, I do think this is shorting to ground. So this can happen even if you've done a perfect job digging out the .0 point on the board. You can tell that this is shorting to the ground layers, above it. So this big solder blob here is touching these ground layers. There's not even actually solder mask on those ground layers. I'm gonna have to get this solder off of here and clean up a bit more before I can tell for sure how far down they went. But before I do that, I do want to check in diode mode with red on ground and black on this point. Yep, we still do have a short to ground on this point. So I think this big solder blob is just connected to one of the ground planes. And my guess is as soon as I pull this off and remove this excess solder, let's just get that off. And you can see that that ground plane there was shorting to it. And unfortunately, I think this person dug way too deep into this board. That is at least one layer lower than it should be. So I may actually need to stop this particular repair here before going further and reach out to the customer to see if they want me to attempt a multi-layer trace repair on this, because I'm almost positive here that they went too deep. I think they went one layer too deep. And the reason I'm pretty sure it's too deep is because I'm counting these ground layers. You can see one here that's tinned. This is actually probably not a ground layer and probably is the trace that goes from here down through here. You can see this trace is about this thick and overlaps with this here. So I think that's that trace, but that still is layer number one. But then you can see if you go down another layer, we have this copper layer here. So that's layer number 2. And then we have layer number 3, unfortunately, which you can see was dug through as well, which is this copper layer down here. And the hole is deeper than all of those, which means they dug straight through the 3rd layer and are soldering to the 4th layer, which very likely means that the .0 point is severed from the SoC. So this point right here, even if it is, maybe the lower layer of the .0 point, it's very likely that this is no longer connected between the SoC and the NAND, which means that even if we were to fix everything else wrong with this console won't boot until we restore that connection. There are a couple ways we could go about doing that. Unfortunately, all of which require quite a bit of work. So I'm going to have to reach out to the customer to see, what they're comfortable with me doing. Clean this up here. This may actually be fine in the sense that all of these sides of these 3 caps may actually be connected to the same rail already, but obviously we don't want to just assume that. One of the things I found helpful for clearing bridges like this is to get some flux in there and get a really thin little tool like this. And we're going to use hot air actually instead of the iron. Getting your iron in these little tight spots can be very difficult, but I find that you can use your hot air and get the solder nice and melted, and then you can just pull a tool like this through, the area that you don't want bridging. I'm just going to wait for this to liquefy, and then we can just sort of do this kind of thing. And you can see that did a really good job of just clearing the bridge there. So there was a little bit of solder between here, and just by heating up the board with some hot air and pulling a little thing through it like that, we were able to get rid of the bridge. This is also definitely ground, and that is also ground. So all of these are already connected. So that little solder blob, unfortunately, probably wasn't our issue either. And again, it's very likely going to be that kamikaze area that was dug out too much. So just in case that still is connected, we can attempt to boot the console via the bench power supply, and we can monitor current draw to see if it gets stuck in first stage boot. If it does, we can be pretty sure that's going to be the cause of our issue, is that they just dug too far down with the kamikaze method. So I'm going to use this thing that I built on my previous live stream. And by the way, I'm streaming every week at 4 p.m. Eastern on Thursdays. And we're doing repairs and all sorts of fun stuff live. So come join me and hang out on Thursdays if you want. But yeah, I built this thing on my previous live stream, which is just a easy way to fake a temperature reading from the battery or from the BMS. This middle pin here is used for the BMS or the battery to communicate to the console. And we're tricking the console into thinking a good battery is plugged in by putting a 10K resistor between ground and that middle pin. So that's all this is here. It's just a 10 kilo ohm resistor. And then this is just, little leads that I can clip my power supply onto. And then we can boot from the bench power. So you can see I just clipped my power supply leads on here, and then we can plug this in and we can monitor current draw of the console when we hit the power button. But before I do that, I want to check for shorts on the main power rail here, because otherwise what can happen is if there are shorts further along down the road, we can accidentally actually kill the BQ chip here by pushing power into the short through the BQ chip from the battery. So we can just check in diode mode from the B6 here, And this is a normal reading from VSys, 0.06 voltage drop. I explained why this is so low in another video that I'll link to in the description. A little bit of an interesting look into how the VQ chip works to supply power to the rest of the console. I won't get too deep into that now, but let's check resistance to ground. And again, from experience, I just know that this normally fluctuates in the sort of kilo ohm range here. Yeah, so that is normal, 3 to 24, and then nothing. I just know my meter does this in resistance mode. So because all of that sort of input circuit stuff looks normal to me, I'm comfortable plugging this in and applying 4.2 volts to the battery terminal here. So I'm just gonna turn my power supply on now. I have a 2 amp current limit set because it needs just over an amp to boot. So if you don't give it that 2 amp current limit, sometimes it can prevent boot actually. So we're gonna turn this on, and this is a good sign already that it's not pulling current into the console because we haven't told it to turn on yet. So already a good sign that the device is not taking power when we haven't told it to by either plugging in a charger or pressing the power button. So we're just going to press the power button here, and we can see it goes up to 100 milliamps, and I think it's just going to get stuck here based on what I saw over here, where that 0 point is sort of severed between the NAND and the SoC. So normally what would happen is we would see this jump up to about 300 milliamps if the console was turning on. But right now this is just getting stuck in first stage boot, which means the NAND is, either not able to communicate correctly with the SoC, or it's initialized in a slower mode, or that kind of thing. So in this case, unfortunately, the customer is kind of out of luck. They dug too deep, and in order to repair this, I'm going to have to dig a few layers into the board and do some multi-layer trace repair. It's possible that just too much of those lower layers were damaged for me to do anything. This looks honestly salvageable potentially, and if it is, I'll make a separate video on that. But for now, I hope that was helpful in terms of how I sort of approach a repair. I didn't know what I was going to find in here, to be honest, so all of that was just my first reactions to everything and just sort of my thought processes for how I look at a repair when I get one in. This one, if the customer wants me to proceed with it, it's going to be a little bit more expensive than normal, at which point it may, be more financially reasonable for them to just buy a new board. So I'll end the video here because I do have to get confirmation from the customer first. But yeah, don't forget to click the link in the description to enter the giveaway over on Reddit. But otherwise, I appreciate you guys for watching, and I will see you in the next video. Peace.